Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. The sequence A1, A2 through AN is defined such that A1 is equal to minus 12, A2 is equal to A1 by 3, A3 is equal to A2 square, and then AN is equal to AN minus 3 for n greater than 3. We have to find the sum of the first 20 terms of this sequence. So the fundamental approach to any problem that involves series and sequence is basically trying to find a pattern. If there is a simple pattern that you can discern from the description that's given. So we'll follow the same approach here. So we'll write out what's given. So A1 is minus 12, A2 is A1 by 3, and that makes A2 equal to minus 12 divided by 3, which is minus 4. And then A3 is A2 square, which is minus 4 whole square, and that comes to 16. And then for n greater than 3, we have AN is equal to AN minus 3. So if we write what F4 will be simply A4 minus 3, which is A1. So A4 is A1, and A5 will be A2, and A6 will be A3. And then you can go on to further show that A7 is equal to A4, but A4 is equal to A1. So we can write that as equal to A1. Similarly, A8 is equal to A5. And from the previous three set, we have found that A5 is equal to A2. So we have A8 equal to A2. And finally, A9 is equal to A6. And that will be equal to A3. So what we are finding in this particular sequence is there's a pattern, there's a repeating pattern. So the terms repeat in blocks of 3. So we have A1, A2, A3, but then A4, A5, A6 are also equal to A1, A2, A3, and so are A7, A8, A9. Now, this is itself an interesting pattern, but what makes this problem really easy to solve is further noting that if we add up these three terms, A1, A2, A3, which seems to be repeating throughout the sequence, right? If we add up, if we simply take the sum of these three, A1 plus A2 plus A3 becomes minus 12 minus 4 plus 16, which is simply 0. So all of these terms, A4 plus A5 plus A6 will be 0, A7 plus A8 plus A9 will be also equal to 0. So what we are seeing here is basically for summation up to 3m terms, meaning for summation of terms that are multiple of 3, the series basically vanishes, right? Because if you take this the term of these three terms, A1, A2, A3, which kind of keeps on repeating, that is 0. So we have 0 plus 0 plus 0, and so the sum up to 3m terms simply vanishes, right? And further, we note the term that immediately follows the 3mth term is simply equal to A1, because that's the repeating pattern, right? A1, A2, A3, then again A1, A2, A3, and so on. So the term that follows the 3mth term is simply equal to A1. So now we consider the sequence, the sum of the sequence that we are asked to find, which goes all the way from 1 through 2020, right? Now here it's useful to note that 2019 is a multiple of 3, because if you divide 2019 by 3, you get an integer quotient, right? 673, there's no remainder. So 2019 is divisible by 3, and the quotient is 673. So that's useful to note. Now, if we take the series, the sum of the series A1 plus A2 plus A3 plus all the way till 2020, of course 2019 is the term before 2020. So if we consider the sum through A1 to A 2019 being a multiple of 3, this sum will simply vanish. It will simply be 0, right? So we are simply left with A 2020. Now remember that A 2020 is the term following A 2019, so it's the term following a 3mth term, because 2019 is a multiple of 3. So that will make A 2020 simply equal to A1. And we know that A1 is minus 12. So the sum of the first 2020 terms of this sequence will be simply equal to minus 12.